Hi everyone, welcome to Vedantu English. I'm Diksha Kaushal, your chemistry master teacher. So everybody do let me know in the chat box if I'm clearly visible and audible to all of you or not, so that we can start with the chapter that is thermodynamics, right? So everybody let me know in the chat box if I'm clearly visible and audible to all of you. Yes, Abhi, Mutra, Ujjwal, Anjali, Zenith, Dragon, Janani, Sugan, yes. So today we are going to discuss thermodynamics. It is divided into three parts. So small parts it is divided into. Today we are going to do the basics of thermodynamics, the uh, terminologies of thermodynamics, and we are going to discuss the work related formulas of thermodynamics, right? So everybody ready? Yes, green hearts in the chat box if you are ready for the class so that we can all start with the class, right? Okay, so uh yes, okay, yes. Now let's see some important terms, right? So what are the important terms of thermodynamics? This is the field of study that deals with the various forms of energies and their interconversion in physical or chemical change. It also predicts the feasibility of reaction under a given condition. So when I talk about feasibility, that means we are talking about whether that reaction will occur or not, right? Whether that reaction will take place or not, right? So take place or not, that we will tell about with different things like Gibbs Helmholtz, like you have Gibbs free energy, Gibbs Helmholtz equation, that is criteria of spontaneity, which is a very important question that we'll discuss in feasibility. Rest of it will discuss about interconversion of physical and chemical properties, how the reactions are changing, what are the changes that are occurring here. For that, there are some basic terms that you must know about. First is the system, right? So there are three types of system that we have. One is open, then there is closed, then there is isolated system. In an open system, there is exchange of energy as well as matter. Ma'am, what kind of open system? You have a glass of tea or coffee, whatsoever you like, right? It is not covered, right? So what is happening when you have a glass of tea that is not covered? What is happening in that case? You are also exchanging the mass because some amount of tea is getting vaporized here, and the heat energy, because we know that after some time that tea is going to cool down, right? That is the reason that why it is cooled down, because the heat is also exchanging here. So two things are exchanging here, energy as well as matter. Matter in the form of vapors that are getting exchanged, and energy in the form of heat that is getting exchanged. Then in a closed container, now here let's assume you have a cup of coffee which is covered, okay? It is totally covered. So if I say this particular coffee is totally covered, that means there will be no exchange of mass here, because whatever are the vapors that are getting formed here, they are not coming out of this a lid that is there on the top, right? It is not coming out. So that means there is no matter exchange, mass exchange is not there. But can you see, if you cover a cup of coffee, right, even then it will cool down, right? Even then it will cool down after some time, right? It's not like it will not cool down, it will stay hot only, it will stay warm only, it will not happen. So here we can say that the exchange of energy, the exchange of heat energy is there, right? But there is no exchange of matter. Matter is not exchanged here, right? Then let's talk about third thing, that is isolated system. What is an isolated system, guys? Everybody, what you use in high isolated system? Yes, that we'll talk about, right? Don't worry, but don't worry, you are here now. I'll teach you everything, right? Important topics as well, right? And important topics will be in more detail, right? Most of the things that I'm discussing are important only, right? So isolated system is no exchange of energy is there, no exchange of heat is there, right? So no exchange of energy, no exchange of mass is there. Any example that we have in our daily life? The thermos bottles that we have, right? Thermos bottles that we have. In winters we use those bottles in which whenever you add a hot water, it will remain hot, and there is no 100% isolated system. We know that even in a thermos bottle, you add water, hot water, after maybe 10 or 12 hours, it will little bit, it will cool down, right? So no system is truly isolated, right? Truly isolated system is not your thermos bottle. That is not truly isolated system, but it is almost 99.9% isolated, because it can still stay hot for some amount of time, right? Okay, yes. Then let's talk about, okay, this is the thing. In open system, energy is getting exchanged, mass is getting exchanged. In closed, only energy is getting exchanged. In isolated, no mass, no energy is getting exchanged here. Now let's talk about what is surrounding, right? So this is a universe, right? Let's say I am the system, right? I am the system. Ma'am, weightage. This is a very important chapter, guys. You can expect around three questions from this chapter. It's important, right? And it's predictable. Not very difficult questions are asked from here, right? Very predictable questions are asked from here, right? Okay. Yes. Tell me about it. If I say this universe, right? I am the system. Then except from me, everything that is there will be the surrounding. That means in a universe, if you subtract system from there, everything else that is left behind is the surrounding. For example, I am focusing on this particular bottle, okay? So this is my focus point. This is the thing that I want to focus on. This is the system that I am working on. So everything in this universe, me, you, we all are surroundings. Me, you, Mars, planet, Earth, planet, anything, everything else is surrounding here, right? So universe means system plus surroundings, right? System plus surrounding will make the universe, will make the universe. This is thermodynamics language, okay? Then boundary. What kind of boundary is there, right? So the wall that separates system from the surrounding, that is called as boundary. Now that boundary can be visible, that boundary can be invisible, right? So it can be real or imaginary. Real means it is visible, imaginary means it is invisible. There is no rigid boundary here. So if you talk about this balloon, right? Now let's say I have gas, let's say helium gas inside it, right? So that helium gas is my system. So this will be the defined boundary that you will have. This is the defined rigid boundary that you have, right? Sometimes we are talking about some gases, right, that they don't have a defined boundary from the surrounding, right? Okay, real or imaginary boundary can be there. Now this, if I say this is a boundary, this is the surrounding, this is the system, right, and this is the piston, and this is the boundary. The boundary can be isolated, it can be non-isolated. Let's talk about that. If I talk about two kind of boundaries can be there, right? First thing is adiabatic boundary. Now what do you mean by adiabatic? In adiabatic, there is no exchange of heat. Whenever you have adiabatic boundary, heat exchange will not be there, right? So no heat transfer is allowed in case of adiabatic boundary. No heat transfer is there, right? Then made of insulating material. It is made up of insulating material, right? Okay, insulating means that does not let heat transfer from the system to the surrounding. Heat transfer is zero, right? If I say this boundary is adiabatic, that means no heat exchange will be there. If I say this boundary is diathermic, in that case heat transfer is there. So you can say heat transfer is there in the diathermic boundary, because they can give you in the question that this is diathermic, this is adiabatic boundary. So you must know what we are talking about regarding these boundaries. It is made up of conducting material. That means the conducting, the transfer of heat is there, right? Then it's a copper vessel, right? For example, a copper vessel that allows the transfer of heat, right? Then two very important terms, intensive and extensive property, right? Okay, yes, everybody, tell me if the basic is clear. Ma'am, please answer. Yes, Pritaja, I don't have that much time. See, DNA batch, Sigma crash batch, right? Now your JEE classes, right? Now I'll also have to revise the DNA batch, right? So many things are there, right? So I don't have that time to see quotations, right? So yes, intensive properties, intensive and extensive properties. Just remember, in for intensive and in for independent, right? In for independent, in, that's how you can remember this. Intensive properties are independent. Ma'am, independent of which thing? Intensive properties are independent of the amount of substance that is present there. It is independent of the amount of substance that is present in the system, right? And if you talk about extensive properties, they are dependent on the amount of substance that is present. Amount of matter, quantity of substance, whatsoever you say, mass of substance, right? Whatsoever you say. So intensive is independent, extensive is dependent on it, right? Now let's talk about other things that are related to this thing, right? Properties whose value remain unchanged when system is divided into smaller parts. Intensive is that even if you divide the system into smaller parts, this particular property, the value will remain unchanged. For example, if you talk about pressure, right, it's like you have a container, right, you divide it into 10 parts, even then the pressure that is there, that will remain the same. Temperature, that will also, you divide it into 10 parts, temperature also remains the same. Density remains the same. Density, I'll tell you, it's very important. Boiling point, freezing point, that does not depend upon the mass, right? Then pH of the solution, refractive index, molarities, then you have EMF of the cell, surface tension, viscosity, all of these are not dependent upon how much mass you have taken, right? Now I'll tell you very interesting thing, right? If you talk about extensive properties, properties that change value when system gets divided into smaller parts, when you divide the system into smaller parts, these properties will vary here, right? How come? Mass, if you have, let's say, 10 kgs, that will have a different mass. If you divide it into 10 parts, then it will be 1 kg. So it is dependent of the mass. Volume, if you say, volume will be dependent upon the mass. Now it depends upon that how much mass you have taken. That particular different 1 kg will occupy different volume, 2 kg will occupy different volume. So that depends upon the mass. Then you have heat capacity, right? Heat capacity, will do it in detail as well. As of now, just remember that heat capacity is the heat that is there, heat that is changed when you try to increase the temperature by 1 degree Celsius, right? In detail, we'll talk about that. As of now, just remember that heat capacity is also dependent upon the mass. How much mass you have taken, it will depend upon that, right? 1 kg, 2 kg, 3 kg, they will have different heat capacities, right? But ma'am, here also, ma'am, heat capacity was there. Specific heat capacity, molar heat capacity. Ma'am, specific heat capacity and molar heat capacity are intensive. But you are saying that simple heat capacity is extensive. Why so? What is the reason? That's a very important point. So if you talk about heat capacity, that is represented by C equals to Q by T. That is dependent upon the mass. If you talk about molar heat capacity or specific means Q by MT. That means specific means I am telling that I am talking about only one unit mass. If I have fixed the mass only, then how come it will be dependent upon the mass? I have fixed it that mass is 1 kilograms. So now it is becoming independent of the mass because now I have fixed that quantity itself. That is why anything which is specific will have independent, that means it will be independent of mass, that means it is intensive. Molar heat capacity is represented by Cm is Q divided by Nt. Now ma'am, what is this Nt? Achha, now understand one point. Here you have delta T. Okay, here what you have is delta T. Okay, change in temperature is there. Detail will talk about heat capacity, right? So right now just see that why, which is intensive, which is extensive. This is molar heat capacity. That means I am defining heat capacity for 1 mole. Now 1 mole means, see, molar mass is fixed. Number of mole is equals to mass by molar mass. This is a fixed quantity for a compound. If I say this is also fixed. If I say number of moles, I am saying 1 mole only I am talking about. Then that means mass also I have fixed, right? So if mass is fixed, then how can it be dependent upon the mass? So that's why specific and molar heat capacity are independent of the mass, right? Then if you see one more thing here, that is density, right? That is density. So if you focus on density, what is density? Tell me density. What is density? Density is equals to mass by volume. Density is equals to mass by volume. And if you have noticed, mass is extensive property. Volume is extensive property. So when you divide two extensive properties, the result will be intensive property. That is the reason density is intensive in nature. Okay, density is intensive in nature, right? Okay, yes. Tell me, yes, August Tanu, ma'am, this part is easy, but later part, this chapter is so hard. I am here now. Do you trust me? I'll make this easy for you. Trust me, I have taught this lecture, this particular chapter just now in Sigma Crash Batch. Last week only I have taught them. And the students were like, ma'am, this chapter is so easy. Ma'am, so easy chapter. So don't worry about that, right? Don't worry. That's to make things easy for you. That's my responsibility. Okay. Now, extensive property when seen per mole per gram, that means molar or specific, becomes intensive property, right? Example is enthalpy is extensive in nature, but molar enthalpy will be intensive. Mass is extensive, but molar mass is intensive in nature. Okay, yes everybody. Class duration will be, I think by 10:30 or so will be free. 1 hour more, right? 1 hour more you have to focus here, right? Then the ratio of two extensive properties is intensive property. As we have discussed, mass divided by volume is nothing but density, which is an intensive property, right everybody? Now let's discuss about the states. And from intensive and extensive property, its examples, directly the questions are asked, right? So you must know the examples of intensive and extensive properties. That is very important. Very easy questions are asked from there, right? Then state, it means the condition in which system is present. It is gaseous, is it liquid? What kind of state is that? The state of the gas inside the cylinder can be defined by mentioning the pressure, volume and temperature, right? The gas is inside it, right? And we mention it by P, V, T, right? That is how we mention the state. State function, now let's discuss what is state function and what is path function. State function is property of a system which is dependent only on the current state of the system. It is independent of the path, right? So state function is independent of the path. It does not depend. You want to go from this point to this point, you go this way, you go this way, you go this way, it doesn't matter, right? It does not depend upon the path. It only depends upon what is your initial state, what is your final state, and that's it, right? So that we call as state function. For example, pressure, temperature, volume, enthalpy, entropy. This is very important. Enthalpy is represented by delta H, right? Entropy is delta S. Gibbs free enthalpy is delta G. We'll discuss all of them in detail, right? And internal energy is defined by delta U, right? Pressure is P. That also does not depend upon the path. Temperature does not depend upon the path. Volume does not depend upon the path. So PVT and UGHS. PVT, pressure, volume, temperature. UGHS, internal energy, Gibbs free enthalpy, and then entropy. All of these things does not depend upon the path that you have taken. Changes in state function are not state function. So what we are saying that if you say delta H, delta S, delta G, delta U, this so we know. But if you say, ma'am, delta T, delta V, delta P, etc. are not state functions. So what we are saying that changes in state functions are not the state functions. It's a very important statement that if you see the change in the state function, this is not the state function. Temperature T is the state function. Delta T is not a state function. Temperature is a state function. Pressure is a state function. Volume is a state function. You can't just add delta over there, right? Okay. Then if you see path function, right? Path function, quantities which depend upon the path, right? So there are two very important quantities that depends upon the path. First is heat, that is represented by Q, work, right? Then molar heat capacity, that is Cm. These are dependent upon the path that you have taken, right everybody? Okay, yes. Now let's see this very simple question. Which of the following are state functions? So state functions are what? If you must know, there is a formula that is G is equals to H minus Ts. So this is nothing but this, they are talking about G. This is actually Gibbs-Helmholtz equation that we'll talk about later on in this chapter. I think Friday's lecture will be based on Gibbs-Helmholtz equation. We'll discuss that in Friday's lecture. Okay. So it is going to be G here, this is W, this is Q, and what is Q plus W? This is nothing but this is delta U, right? So which of the following are state functions? State functions, this is state function, first and fourth are state function, right? So 1 and 4. Because from the first law of thermodynamics, you can say Q plus W is equals to delta U. So that's why we can write first and fourth are the state functions. Ma'am, how you named this? Ma'am, how you named this? These things now we'll discuss later on in this class, right? As of now, just remember that this is nothing but this is G, and this is nothing but this is U. This is delta U. Okay? Right, everybody? Tell me. Yes, ma'am, please explain state function. State function, beta, that depends, that is independent of the path. It all does not depend upon the path. Like you have pressure, temperature, volume, enthalpy, entropy. They just depend upon the initial and final value. Right? Okay? Okay. Now next is types of processes. So what are the different types of processes? Let's talk about that. A path through which change of state of system occurs, right? So let's see different types of processes here, right? Okay, everybody. Wait a minute. So wait a minute. So what are these different types of processes? Let's talk about that. First is isothermal. Iso means same. Okay, iso means same. Iso, you mean it is same. Iso means same. So if I say isothermal, that means temperature is same. If I say isobaric, bar is the unit of pressure, so pressure is same here. If I say isochoric, choric means volume, so that's why volume is same here. Adiabatic means heat is constant here, right? So temperature constant means change in temperature is zero. Pressure constant means change in pressure is zero. Volume constant means change in volume is zero. And heat constant means change in heat is going to be zero. Right? So let's talk about the graphs of isothermal, adiabatic, all these processes. In case of isothermal, now what you will do here, right, simply will do this one thing, that is, tell me what is ideal gas equation. What is ideal gas equation, everyone? What is ideal gas equation? That is PV is equals to nRT, right? That is your ideal gas equation, right? Now if I talk about ideal gas equation, I am saying that number of moles are already constant, R is a constant, universal gas constant, temperature in isothermal is constant. That means these all terms are coming out to be constant here. That means I can say PV is equals to constant. So this is the equation for isothermal, that PV is constant. That means, can I say that if I say P and V are constant, that means we can say that P is inversely proportional to V, right? So whenever two things are inversely proportional to each other, whenever you have a graph of x inversely proportional to y, in that case, that graph is curved. It is a non-linear graph with this kind of slope. Okay, so that is a curved non-linear graph. If I talk about volume and temperature, because temperature is constant, so at one temperature, so for one particular temperature, you will have, for one particular temperature, you will have so many volume here, right? That is a straight line parallel to volume. This is a straight line parallel to pressure because temperature is constant here, right? Then we talk about isobaric. In case of isobaric, guys, what you have? In case of isobaric, what you have? Tell me, everyone. In case of isobaric, we can say PV is equals to nRT. Now, pressure is constant, nr is constant. That means V is directly proportional to T. So they are directly, whenever X is directly proportional to Y, that is a linear graph. Okay, when X is inversely, when two things are inversely proportional, that is a non-linear graph. When two things are directly proportional, that's a linear graph. So volume and temperature are going to have a linear graph here, right? Or you can also write it as V is equals to KT, where K is the constant, so you can compare it, Y is equals to mx. So if V is the volume, T is the x-axis, y-axis is volume, x-axis is temperature, then slope will be positive here. Slope is positive here, right? Okay. Now if I say that pressure with volume, because pressure is constant, so this will remain constant and volume will change. Here pressure is constant and temperature will change, right? Then next is about isochoric. Now in case of isochoric, what you will see, that volume is constant, moles and R are constant. So we can say pressure is directly proportional to temperature. When I say pressure is directly proportional to temperature, that means pressure and temperature are going to have a linear straight line graph here, right? That is not parallel to x or y axis, because when you compare this with y is equals to mx plus c, There is intercept is 0 and the slope is positive here. That's why here slope is going to be positive. Tell me if that thing is getting clear to all of you, right? It's a very simple thing. From ideal gas equation we are picking that, right? Now we are saying volume is constant, so this will remain constant and temperature will change. Volume remain constant and pressure will change, right? Okay, tell me. Now let's talk about next kind of process, that is cyclic process that occurs in a loop. You go from one point, da 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 da, you come back to the same point, right? So tell me one thing. If you start from your home and you come back again to your home, right? Now you have done work, you have gone out of the home, you have gone to your school, you have gone to some other place as well, hang out with your friends and all, then you came back home, right? But your place, final and initial, is same, right? So maybe to your father, right, to whom it is not, it doesn't matter that you have gone to school or you have studied also, he is like, whenever I come back home you are in the same position, whenever I go back to office, when I go to office, you are in the same position, right? You are not just getting out of your bed only, you are like, but dad, I went to my school, I am just now back. Why are you saying my position is not changed? Because for your dad the path does not matter. For him the state, he is like, he is independent of the path. He is like, your final and initial state is same. In the morning also you were not studying, now also you are not studying. For him you are not studying, but you know that whole day you have studied, right? Relatable, right? So same thing is happening here. So all the state functions that are independent of the path, like your father, right? To whom it doesn't matter that you have gone to school and all, is like, okay, you are in the same condition in the morning, in the night as well. You were in the night suit in the morning, now also you are in the night suit. No change is there, right? So for him, your delta, the change is 0. That means we can say the change in the state functions will be 0 in the case of cyclic processes. In cyclic processes, all the state function, their change is 0. We call it delta T, delta V, delta P. Then I'll also write other things, that is delta S, you call it delta S is 0, delta U is 0, delta G is 0, then delta H is 0. All these processes, all these things will have 0 change in case of cyclic function, right? When a system undergoes a number of different states by different processes and is finally returned to its initial state, it is said to have completed a cycle, and the process is called a cyclic process, right? So let's talk about cyclic process here. Acha, now I'll talk about each and every single line here, that what does it represent. Okay, now these things are very important for you. When you see the questions, these things will matter a lot, right? Now remember one thing, that whenever I say, let's talk about A to B. Now in A to B, can you see one thing? Tell me firstly, in A to B, what is happening? In A to B, pressure is constant, volume is increasing, right? So volume is increasing. Volume is increasing. Initially it was this, now it is this. So volume, when it is increasing, it is a case of expansion, right? So when expansion, when you give the temperature, right, the molecule will expand. That's why expansion is related to heating, right? So we can say A to B, volume increases, expansion. That means we are talking about heating here. In B to C, volume is same. What is happening here? Tell me. Volume is same. Pressure here is decreasing. Can you see arrow is down? So pressure is decreasing. Achha, tell me, if pressure is decreasing, pressure and volume are inversely proportional. So we can say volume is increasing. So again, here volume is increasing, pressure decreasing, pressure is decreasing. Pressure decreases means all the molecules are going away from each other. Volume is increasing, expansion, heating, right? So next is C to D. Here you will see pressure is constant here, pressure is not changing here, right? Or you can just directly write this, C to D, pressure is not changing but volume is decreasing. When volume is decreasing, it is a case of compression, it is getting compressed, and compression means cooling, right? So it is cooling. D to A, D to A. Now in this case, pressure is increasing. Whenever pressure, you're applying a lot of pressure, whenever there is application of pressure, the system is getting compressed. When someone puts pressure on you, are you happy? When you say pre-board is there, ma'am, ma'am, there is none, JEE means, ma'am, so many things are there, ma'am, you feel happy. Finally exams are there, you're under pressure, so you're already compressed, right? So when pressure is there, when you apply more pressure, system is compressed and cooling occurs, right? Okay, tell me everybody if this particular thing is clear to all of you or not, right? If this thing is clear to you all of you or not. Sarada, you will have your class, it is fixed that you have your class on Friday and Saturday. By this week, this chapter will be finished. Okay? Friday and Saturday, you will have your class. Right? Okay? Done? Yes. Now, these are just the chart. You can go through this isochoric, adiabatic, cyclic, all the processes are written here. Right? Then let's talk about reversible, irreversible. This is also a very important kind of process that students usually get confused in, right? Yes, yes. Now let's see, definitely not, है ना, mismatched photo, definitely not, right? अच्छा, आधार फोटो तो all of us look different in our आधार photo, don't worry about that, right? It's not like your full face is changed, right? You have done plastic surgery on your face now, right? There will be similarities, right? Obviously people change, right? But yes, now let's see reversible processes, right? If you talk about reversible and irreversible processes, let's talk about, this is a very important thing. They don't directly ask you reversible and irreversible, but in terms of the questions, it is asked that what is reversible, irreversible process, that is asked, right? Okay, so let's study that. So first is reversible process, that is quasi-static process. It is infinitely slow process and takes infinite number of steps for a finite change, right? So in a reversible process, it is a very slow process. You know what I'll do first? Before teaching you, I'll teach you this diagram, right? So that from this diagram, it will get more clear, and then we will study the theory points. Then you can easily understand the theory points as well. Okay, let's talk about this here. Let's talk about this here. Chalo, let's talk about this here. Okay. So what you can see over here, can you tell me? I'll just write it in a beautiful way, right? Rather than this way. Okay. See, this is a reversible process. This is a reversible process. In a reversible, as the name says, you will form products and then you will go back and form reactants as well. That means this particular process is not towards the completion. No completion here. So first point to write down here, no completion. No completion is there. It is always going. That's why we say it is very slow process, because it's so slow. It will move forward, then it will again come backward, then again little bit forward, then again backward, again forward. That's why it is such a slow process. That's why it is a very slow process, right? Then very important point, that in this case you don't have a big block here. you have small masses. For example, that you have a yes, for example, you have a this soil, right? So how you are decreasing the pressure, you are sorry, increasing the pressure. How you are increasing the pressure? You're increasing the pressure not by a big block of mass, right, but by just simple soil particles, right? That's why every single particle is putting pressure on this particular gas that is filled inside the container. And it's not like it's a situation where you are learning right now, okay? It's a situation when, for example, you are learning in a very slow way. You're not learning through one shots, you are learning through detailed manner. This is what you're doing. So that is slow process, and every single thing is happening in short lectures, right? Okay, so that is why it is a very slow process. Now, a very important point here to highlight, that because it's a very slow process, here can you see variable pressure we are using? Sometimes maybe a big soil particle, sometimes a small soil particle, sometimes three soil particles can attack here, right? So what we are doing here, we are using variable external pressure here. So you can write variable external. The external pressure is variable external pressure. So what we have here is variable external pressure, right? Okay. I think that's it. Variable external pressure is there, no completion. It's a slow process, and it is a multi-step process. Multi-step means it will not take part in just one go, right? It is a multi-step process. So any of this is written. For example, reversible, they have not written. They have written any of this, that means they are talking about reversible. And because it is taking part in small steps, right? You can write it here, small steps, right? That is the reason whenever things are taking place in small steps, we do integration. And in this case, you will use integration formula, right? Okay. Now let's talk about irreversible process. First thing is, it is not reversible. That's why it will undergo completion. There will be completion of this process, and it's a fast process, right? It's a fast process, right? Now when I say it's a fast process, next is, it's a fast process because one big block is putting the pressure. Suddenly it will drop down to this path, right? So that means it's a fast process, it's a single step process. You can say it's a single step process. Single step process, and big change is there, right? You can say small steps, and you can say big step. Big step, big change. That's why we use, here we use delta, right? That is the reason here we use delta, and here that is the reason we use d, and that will lead to integration, because whenever there is differentiation, it will lead to integration. Okay, because d defined for small steps, delta is defined for large steps, right? Okay. Now let's talk about that, what is the kind of pressure will be there. It is a constant external pressure, because only one big block is there, so a constant external pressure is there. Constant external pressure. Okay, constant external pressure. Right, everybody? Tell me in the chat box. Right? Okay. Definitely, we will take Ayush. Definitely, when the time is right, we will start taking for AEEE as well. Okay, don't worry. Right? Okay, last year also we have done that. Right? Okay, let's do that now. Let's see these things here, the points here. So tell me if there is any problem in this particular thing. Constant external pressure, variable external pressure is a very important statement. They directly sometimes don't tell you that this is reversible, this is irreversible. Because students, the biggest problem, I'll tell you, it's a very important question for your JEE is, even as for NEET as well, for any competitive exam, right? And especially for JEE, it is isothermal reversible or isothermal irreversible. Now, if they directly tell you that you have to apply here isothermal, this is isothermal reversible process, then it's okay. You know the formula, you can apply. But sometimes they don't directly tell you that this is reversible. So in that case, you should take hint from these points that I have written here. Right? To understand which formula to apply, you must know these things, right? So all the things that we are discussing, some, students find thermodynamics very tough. Reason being, ma'am, I know the formula of thermodynamics. Ma'am, I know isothermal reversible formula. Ma'am, I know isothermal irreversible. And still I'm not able to solve the questions. Why? Because you don't know what is reversible. You don't know what is irreversible process. You don't know which formula to apply where. That is the main problem of thermodynamics. Students don't know which formula to apply where. It's not like formulas are difficult. The application, where to apply what is, even the application is easy. But which formula to apply where, that is tough part here, right? Okay. So let's see this now. We'll do that, Abhijit. We'll do questions as well, right? So that's why I have divided it into 3 parts, right? So reversible process, quasi-static process. It is also called as quasi-static. This is very slow process, take infinite number of steps. I told you multi-step process. This occurs when pressure difference, what we are saying, when pressure difference or temperature difference between system and surrounding is very small, right? So can you see the pressure difference will be very small. Very small changes will be there, right? That's why integration formula we will use here, right? Then deriving forces, opposing force at every step. So why it is reversible? Why it is getting backward again and again? Because there is some opposing force that is making it go backward again and again. Both system and surrounding are at thermodynamic equilibrium at every instant. At every instant, there is thermodynamic equilibrium. It is a hypothetical process. So basically, all the natural occurring processes, this is one thing that students miss on. Natural processes are irreversible processes in most of the cases. Like 99.9999% natural processes are irreversible. That's why we are saying reversible process is hypothetical process. It's an imaginary process, right? Now let's see what is thermodynamical equilibrium. A system and surrounding are in thermodynamical equilibrium when mechanical equilibrium, thermal equilibrium, and chemical equilibrium exist between system and surrounding. When the mechanical change is zero, that means pressure is zero, thermal change is zero, equilibrium, chemical equilibrium exists, that is your thermodynamical equilibrium, right? Okay. Now, when the path of reversible process is reversed, then both the system and surroundings regain the original state. That means when we are saying that when the path is reversed, it was moving forward, it is moving backward, it is regaining its reactant position, it is regaining its original position, right? Now let's talk about irreversible process. This process gets completed in definite number of steps. That means there is some specific number of steps in which it is getting completed. So this process is getting completed in some specific number of steps. It's not a multi-step. You will have a large pressure, a constant pressure that is applied, and in single step or very less amount of step, indefinite amount of step, it will be done. A real life process are irreversible processes. There is finite difference in temperature and pressure. That's why we define it by delta P or delta T. The expansion compression takes place against constant external pressure. Now this is what I told you, that there is constant external. This is a very mostly used thing that you will see in numericals. Variable external pressure, constant external pressure. Constant external pressure means irreversible. Variable external pressure means reversible. Okay, so that you must know. Then if there is sudden change in the process, is irreversible, right? So sudden change directly from this to this, that is irreversible. In irreversible processes, thermodynamic equilibrium exists only at initial and final states. So it's not like equilibrium will be there throughout this process. It is only in the initial and the final states, right? When the path of irreversible process is reversed, either system or surrounding or both do not regain original states. So in reversible process, when it is reversed, system and surroundings, they regain their original states. But in case of irreversible, if you forcibly you reverse this process, it will not go back to its original state, because it is not made to go reverse. That's why all the naturally occurring processes are irreversible, and if you want to reverse something, right, it will not regain its original shape, right? Okay, yes, tell me. Tell me, everybody. Clear? Okay, yes. Yes, everybody. Tell me in the chat box. And also do like the session, guys. Like the session, hit the like button if you are liking the content that we are giving you, right? Okay, yes. Now let's see zeroth law of thermodynamics. This is not important. I say I am telling you because it is there in your syllabus. It states that two system A and B are in thermal equilibrium with the third system C. Then system A and B both will be in thermal equilibrium. It is saying that in maths you must have done, if A is equals to B and B is equals to C, then C is equals to A. Same thing. Same thing. If A and B are in thermal equilibrium and B and C are in thermal equilibrium, then A and C will also be in the thermal equilibrium. That is zeroth law of thermodynamics, right? Two system and this, then they will be thermal equilibrium with the third system. These two are in thermal equilibrium, so these two are also going to be in thermal equilibrium, right? Okay, yes. Now, as I told you, thermodynamical equilibrium, what do you mean by that, right? So what we are saying, what is thermal equilibrium? That is, see, mechanical equilibrium means there is no macroscopic movement in the system. Movement is not there that we can see, right? Chemical equilibrium means rate of forward and backward reaction is same. Thermal equilibrium means when the temperature of system is equals to temperature of surrounding. That is called as thermal equilibrium. Okay, yes, tell me. Yes, everybody? Okay. Okay, importance of zeroth law. If the thermometer shows, this is important, shows same. Now this is the application part is important here. If the thermometer shows same reading with both cups, we can say that temperature is same for liquids in both the cups only because of zeroth law. See, you have cup number A, there is water in this. You have cup number B, there is water in this, right? So thermometer is showing same reading here. Let's say here it is showing 50 degree. Here also it is showing 50 degree. That means these two are in thermal equilibrium with each other. Because this temperature is in thermal equilibrium with thermometer. This is in thermal equilibrium with thermometer. So they both are of the same temperature. So that's how this is like, I know this might be, ma'am, what is the big deal in this, right? That to ma'am we know only, right? I know you know this, that's why this is not asked to you, but back at that time when things were getting discovered, it was a big thing that okay, if A and B are in thermal equilibrium, B and C, then A and B will also be in thermal equilibrium. So that's how thermometer is this is used in thermometer. Right now we find it quite easy, but at that time making an instrument which applies zeroth law was tough. Right, so that's why this is the application of zeroth law. Okay, right. Right, everybody. Now we are moving towards work, right? Very important work, right? Let's see that. So, two kinds of works are there. Let's discuss about PV work, that is mechanical work, or non-PV work, that is electrical work. We're not going to talk about that. We're going to discuss about this thing only. PV work, displacement work, change in pressure or volume is there, occurs due to volume change, to be discussed in this chapter, and this we are not going to discuss in this chapter. This we are going to discuss in this chapter, that is PV work, right? So if you talk about the convention for the work, right? See, tell me one thing. If someone does work for you, right? Ma'am is standing here, all the content ma'am has already prepared, right? You just have to listen. What if you have to do this yourself? What if you have to start reading the book and do this yourself? You'll feel, huh, why I have to do this myself? That means when the work is done on the system, when someone is doing work for you, you are happy, you are positive. When you have to do the work by yourself, when the system has to do the work, when the work is done by the system is like negative. Why I have to do this? If I give you homework, you'll be like, ma'am, why you are giving us homework? Ma'am, I don't want to do it. So when the system has to do the work, system is feeling negative. When the work is done on the system is very happy that I don't have to do anything. Right? So that is the sign convention. Work is done on the system, that means it will compress and that will be positive. Now sign convention in thermodynamics of physics and chemistry are different. Okay, that you must know. Right, work done by the system, that is expansion. By the system, it is expanding. Right, system is expanding, so that work is negative. Okay, yes everybody, that work is negative here. Right everyone, okay, yes. Now, calculation of PV work, right? Just remember that if I talk about this thing, okay, volume is changing. Earlier, this external pressure is applied here. Earlier, this is the volume, this is V initial, this is V final. Now the volume has decreased, right? Let's say the pressure has been applied earlier, this it was here, right? It was here. Now the piston has been moved here to this place, right? That means this is the change in the volume. Initially, the pressure, the volume was here. The volume was here. This was the volume. Now this is the volume, right? So let's say this is VI, that is mentioned here. Let's say this is VF, that is mentioned. This part is VF, this part is VI, right? So external pressure multiplied by, right, external pressure multiplied by this, that means the area under this, area under this. What is the area? Area, we are saying that external pressure is same here, right? And we can say area is equal to P external delta V. So we can write this as work done is equals to, work done is equals to P external delta V. In this case, compression is happening, volume is decreasing. What if expansion is happening? What if I say expansion is happening? Wait a minute. This is this is actually the same diagram only. Chalo, I'll do the opposite, okay? What if expansion is happening? This is the initial and this is the final, right? Then what will happen? Then also P external delta V will be the answer here, right? So work done is nothing. That is work done. You just have to know all of these derivations. You don't have to do, but still I'll tell you this, right? Volume change, if you see, is length into area, right? And here what we are going to talk about, that here it is going to be delta V. We also know that pressure is equals to force by area, right? Let's discuss. Force on the piston is P external into A, that is the area, right? And P external, if work is, W is the work done on the system by the movement of the piston. That means if W is the work done on the system by the movement of the piston, then it will be work is equals to force into distance. Force is what? Force we have seen. Force is equals to P external into area, right? That is the force here. So writing P external into area, that is the force here, pressure into area, right? Distance is, what is the distance? Distance is this length that you have, this length, the change that is there, this is the distance, okay? Area is, this thing is the area, right? And this is the length here. So what we are saying, this is length, distance is the length, how much it has changed. So if I see this area into length, it is nothing but it is delta V. If you see this, volume change is nothing but, volume is what? Volume is also length into area, and volume is also delta V, right? So you can say length into area, you can write the value this as delta V here, right? Now because it is decreasing here, right? So you can write minus delta V here, right? And because it is done on the system, that's why what is happening, this is minus P external delta V minus P external V final minus V initial. That is going to be the work here, minus P external V final minus V initial. So that is the overall work formula. All of these things they don't ask you, it's just that for your own satisfaction I am telling you that this is minus P external delta V. Okay, that is the work done formula, you must remember. Now whenever we talk about a large change, it is written like that. Whenever we talk about a small change, we write it like this. P1, this is P2, oh, sorry, V1, V2, because volume is changing now. This is V1, let's say this is V2, right? Wait a minute. So this is V1, this is V2, this is P external delta V, or I would say write D. Now this I say, this is for, this I am writing for irreversible process, when the large change is there, right? This I am writing for reversible, when small change is there. Okay, tell me, you just have to remember this thing here, you can ignore this whole part, just remember this part, okay? Because this is what they can ask you in the exam, this so they will not ask you this derivation and all, right? Okay, but for your CBSE board exam you must do the derivations as well, but otherwise they will not ask you in JEE or competitive exam, it's not important, the application part is more important. That for irreversible you have large change, for reversible you have small change, that's why we have done integration here, right? Okay, now as you can see here, work in case of irreversible process, that is work is equals to, in the case of, wait a minute, this in the case of irreversible process, yes, if you write it in irreversible process change, because the change is very large, so that's why we write it as work of irreversible is equals to, this is just, they're just showing that even if you write V2 minus V1, even then that's such a big change that in this case irreversible will be minus P external delta V, okay? But in this case, now in this case you have V1, V2, this is dV. Acha, now understand one thing, that in case of irreversible process, the pressure of that gas is very high as compared to external pressure, right? That external pressure is not very large here, right? So pressure of gas is very high as compared to external pressure here, right? But in this case we can see that pressure of gas is equals to external pressure plus this change. So pressure of gas, see, because the change in the pressure, because in the irreversible process the change is large, that's why the pressure of the gas is quite large, right? But in this case the change is dp, which is very small, that's why pressure of gas and external pressure are quite similar. So you can replace the external pressure with pressure of gas as well, and you can have this formula here. Tell me if that is clear. Tell me guys if that thing is clear. In case of irreversible, the change is very large, that's why P of gas is equals to P external plus delta P. That is a big change in pressure, right? So it's a big change, that's why we can say pressure of gas is very large as compared to external pressure, right? But in this case, this is very small change, so they are quite equal. That's why you can replace external pressure with pressure of gas here, right? Okay. But you can only replace it in a reversible process, not in irreversible process. You can't do that. In irreversible, you will use delta V. Here you will use integration dV. Okay, that's the difference that we have. Now let's see this question here, that is, an ideal gas is allowed to expand from 1 liter to 10 liter against a constant external pressure of 1 bar. The work done in kilojoule is what? Right, so they are asking you the work done in the kilojoule. Let's talk about that. What is the work done in kilojoules? So this is an irreversible process. Can I see that? Have they said it anywhere? Yes, ma'am. They are saying against a constant external pressure. A constant external pressure is what? That means they are talking about irreversible process, right? They have given you volume change, they have given you a P external, work done they are asking you. So we know that work done is equals to minus P external, V final minus V initial, minus P external is what? Right, this is given to be 1 bar. Now see, this you have to calculate this in kilojoule. This is 1, this is final is 10 minus 1, that is going to be minus 9. But this is liter bar, okay? This is liter bar, and you must convert this liter bar. This is liter bar, right? Then you have to convert this liter bar into kilojoules. Let's see how to do that. Firstly, 1 bar is nothing but 10 raised to power 5 Kelvin, and liter is nothing, you will convert it into, because liter is nothing, that is decimeter, no? So you will convert it into meter cube by multiplying it 10 raised to power minus 3. So you will convert it here. This will be Pascal meter cube, right? Pascal meter cube, that is nothing but that is nanometer, and nanometer is nothing but that is joule, okay? So you can say 1 Pascal meter cube is equals to 1 nanometer, that is nothing but 1 joule, okay? So you have successfully converted this into joule, then convert it into kilojoule by dividing it by 1000, and you'll have your answer. Okay, so it's a game of unit conversion, and this is your 2019 question. Nothing else was there, it was just unit conversion. Everything else is a simple formula that you must apply here, right? Okay, next is heat. Next fundamental is heat. Now, if you talk about heat, heat may be defined as the quantity of energy which flows between a system and its surroundings on account of temperature difference, right? So whenever temperature, suppose a body is cool, a body is hot, okay, then there will be temperature difference, and because of that temperature difference, the heat will flow. Now you must have seen that if you've ever gone to kitchen, then when your hands or let's say your hands are very cool, okay, they are like literally very cool, right? You touch a pan, and because the temperature difference is large, then the heat transfer also will be large, and it will, like, it can burn your hand as well, right? But what if your hands are slightly warm, right? And then if you touch a pan, still heat transfer will be there, because your hand palm heat is not equal to the heat of that pan, right? But if, let's say, the difference in the heat is very less, then you will not feel that, oh my god, suddenly you will feel a shock by touching the pan. That will not be there, right? Okay, so that's why uh, you see, whenever you have a wet pan, right? You put it on the gas, suddenly excessive heat transfer will be there. You can also see it, right? Because suddenly vaporization will be there, right? But if you have a dry pan, you put it on the gas, right? You heat it, less heat transfer will be there, because when you have water, more cooling is there, right? So heat may be defined as quantity of energy which flows between a system and surrounding on account of temperature difference between them. Heat always flow from, now this is important, it always flows from high temperature to low, and this is from the examples of your daily life. You can see it's not that heat is transferring from you are a cool body to a hot pan. No, from the pan to you it is transferring. That's how these burns and all happens. Why? By heat transfer is there, right? Your body takes that heat, and that's why your hands get burned, right? So IUPAC convention of heat is that if I say energy given to the system, if you give something to someone, they will feel happy. So it is positive. When someone has to give it, right? That means when heat is released by the system, then system feels negative about it, right? So whenever system has to release heat, you can say whenever system has to release heat, they feel negative, right? And whenever system has to gain heat, right, it will feel positive. Whenever it has to absorb heat, it will be positive, right? Okay, then next is internal energy, right? Okay, yes. Now let's talk about internal energy. In case of internal energy, what you have, all the energies that are there in the system, be it translational, rotational, vibrational, bonding, electronic, any other kind of kinetic, potential, all these energies give and makes internal energy. So all the energies in there is sum of microscopic energies possessed by molecule in a system, except gravitational potential energy, that is not in it. Other energies are there in the internal energy itself. If you see, internal energy is contained within the thermodynamic system. Internal energy is the sum of various energies that you have. Absolute value of internal energy, this is important, that its absolute value we don't have. We don't know, does not exist, or is not determined. You can say, instead of does not, say is not determined. Absolute value of internal energy you don't know, but we know the value delta U. Delta U is there, that is U final minus U initial. Change we can see here, and this is an extensive property. That means it will be dependent upon the mass that you take, right? It is dependent upon the mass, right? Now, internal energy, we say that absolute value is not determined, so that's why its change is definitely determined, that is U final minus U initial. Now, if I say that in some books it will be represented as delta U, in some books it will be represented as delta E. You will mostly see delta U, but in some books delta E is also represented, right? So U initial, if I say, what is delta U? U final minus U initial, right? If I say that U initial is greater, if I say U initial is greater than U final, If u initial is greater, then guys what will happen? Everybody tell me. If this is bigger than this definitely, if this value is bigger, this will be a negative value, right? If this value is bigger, this will be a positive value, right? Okay. Internal energy depends upon temperature. Now what we are saying, that internal energy depends upon which thing? It depends upon temperature, right? It depends upon, wait a minute, it depends upon the temperature, right? It's a very important thing. If delta t is 0, if delta, we can say if delta t is 0, then delta u will also be 0, right? Okay. Internal energy depends upon the temperature, pressure, volume and quantity of matter, so it is a state function. So that's why we say it is a state function, right? It's not a path function, right? It is independent of the path, because all these things that it is dependent upon are independent of the path. In most stable form, internal energy of an element is 0. In a stable form, its internal energy is going to be 0 of any element. In a stable form, its internal energies are going to cancel each other, and hence they are going to be 0, right? Okay, everybody, let's do this question now. Let's try and do this question, everybody. Let's do this. Ready, ready, ready? Okay, everyone. Ready, ready, ready? Tell me. Ready? Let's do this, okay? So, case 1, case 2 and case 3. So, in case 1, what you have? They have given you some volume and some pressure. Here also volume and pressure, here also volume and pressure. All of these are cyclic processes. So they are saying an ideal gas undergoes cyclic transformation starting from point A and coming back to the same point by tracing A, B, C, D, A. In all these cases, choose the correct option regarding delta U. In case 1, it is starting from this A, that is 20, and it is coming back to this A, that is 20. Here it is starting from A, that is 10, it is coming back to A, that is 10. Here it is starting from A, that is 10, and it is coming back to A, that is 10. Okay, over here. Pressure and this. So we know that delta U, it does not depend. Tell me if it depends upon this or not. Okay, that will be there, Harshini. That will be there. Don't worry. Right? We just wanted to do some chapters in detail. There were some chapters that we were left with. Right? So I just want to do those chapters in detail for physics, chemistry, and mathematics. Right? Okay? See, that is done. That is done. That is done. But ma'am, delta U is a state function. It is independent. So we can't say case 1, case 2, case 3 are greater or less. In all the cases, it is going to be same only. Can you tell me why? Because this does not depend. All the cases, it is going to be 0. In all the cases, it is going to be 0. Because this is a state function. This is a state function. In a state function, delta U, delta S, delta H, delta G, all of going to be 0 here. And that is your JEE 2025 question based on such a simple thing, right? Okay, does not depend. This is such a simple question, that is. Such a simple question they have asked in JEE 2025, and then you say, ma'am, thermodynamics is, ma'am, very difficult questions are asked, right? Tell me what was difficult there. Chalo. Now let's do first law of thermodynamics. Let's do first law of thermodynamics, everybody. Let's do this. Let's do this. Right? Ma'am, can you please explain this question again? See, here they have asked you, out of the following, which statement is correct? That delta U in case 1 is greater, in case 2 is greater, less, all these things they have asked you. But you know, one thing is there, that delta U in a cyclic process is 0. So whether it is this case or this case or this case, in all the cases it is going to be 0 only. So that means from this equation they all are equal, that is 0. Because state function that is independent of the path, that does not depend upon the path, its value is going to be 0, right? Okay, yes, very good. Okay, yes. Now let's see first law of thermodynamics, right? First law of thermodynamics. Now in first law of thermodynamics, what we are discussing here, I think this image is not clear to you. This is a man that we have. So first law of thermodynamics is basically stating that how work, energy, work, heat and internal energies are related to each other, right? Let's talk about that. First law of thermodynamics was proposed by Helmholtz and states that energy can neither be created. This is a very old definition that we used to study. Energy can neither be created nor be destroyed. However, it may be transformed from one form to another form. It can be transformed from one form to another form, just like from the sun, right? It gains energy, then photosynthesis happens, right? Then we eat it, right? That means energy is being converted to one form to the other form, right? In mathematics we write it this way. Now this is a different equation as compared to your equation of first law in which case first law equation in case of physics is entirely different. This is different because the sign conventions are different. So delta U is equals to Q plus W. That's a very important equation for first law. Very important equation for first law, right? So we can say that change in internal energy is equals to heat energy plus work done, right? Work sign conventions we have already seen. This is mathematical forms of first law of thermodynamics, that whenever heat exchange is there, heat exchange is Q. Heat change, here it is Q. Work done is W. Initially, UA is the internal energy, final internal energy is UB. Then this is the equation that they will have. This is the relation that they are going to have with each other, right? Okay, understood? Heat energy released is negative, absorbed is positive. Work done on the system is positive, by the system is negative in this particular equation here, in this particular first law of thermodynamics equation, right? And also remember one thing, that work is here is minus P delta V. And if you see, for isothermal and adiabatic, the pressure and volume curves are same, but adiabatic will be little steeper than isothermal. Okay, right? That I'll tell you when we'll do adiabatic curve. So this though you can ignore here, hai na? When we will do these things in detail, na, when we'll do isothermal processes, their work done in detail, then you will get to know why it is steeper. Right now I'll just tell you they are steepers, but the reason we'll tell about that in the next class. Okay, so now let's see this question here, and tell me rest of the things do you want to do in next class, because I see students are losing the interest, right? How many of you are not able to understand? Tell me, right? Yes, yes, because some students are here. uh, Vihan Gupta is here, right? He's not able to understand. So I want to know rest of you, how many of you are finding this difficult, because I don't see any difficulty here, right? So it's such a sweet pace I am teaching you, such a slow pace I am teaching you, so that this can get into your head, right? So a liquid, when kept inside a thermally insulated closed vessel. So thermally insulated closed vessel. Thermally insulated means, ma'am, this means that delta T is 0. This is an isothermal process. That means insulated means no exchange of therm. Therm means temperature is there. change in temperature is 0. Closed vessel means here change of mass is also 0. Was mechanically stirred from outside, mechanically stirred from outside. What will be the correct option for the following thermodynamic parameters? Wait a minute. A liquid when kept inside thermally insulated closed vessel. No, in thermally insulated, actually, if it would have been a thermodynamic, they would have not at 25 degrees Celsius or mechanically stirred from outside. Okay, what will be the correct option from the thermodynamic parameter? So first thing is that definitely they are thermally insulated. That means heat exchange is not there, right? Temperature change nahi, heat exchange is not there. If heat exchange is not there, that means I can say here it is Q is equals to 0. So that means the first option is neglected here, right? Then if I talk about mechanically stirred from outside, someone is doing work on the system will feel positive about it. So work is going to be, this is Q is 0, Q is 0 here, Q is 0. Work should be positive, which is here and here. So this is also neglecting. So work is done on the system. Work on the system is positive. So work will be greater than 0. Then let's talk about internal energy. Will it increase or will it decrease? So we are saying that it's a closed vessel. So exchange of mass is not there, right? When the exchange of mass is not there, right? Kept inside a closed vessel at 25 degrees or mechanically stirred. Now mechanically, that means you are increasing its internal energy. That means UF is greater than U initial, and that is the reason delta U is going to be positive here. So answer is going to be B is the correct answer here, right? Okay, or you can also apply first law of thermodynamics here, right? We know that Q here is 0, so work delta U is equals to W. Now if I say work is positive, then this also is going to be positive, right? Okay, work is positive, then internal energy is also going to be positive. So answer is B is the correct answer here, right? Okay, yes everybody. Acha, now we have some processes and then these things in detail, right? So that is like little on the more crucial side, right? Tell me if you want to do a little bit today or you want to do, because if I start there, na, I won't be able to stop in the next 30-40 minutes, right? Because in the next class, what we have in the next class, we have heat capacity, we have all these work formulas will be there, right? Base we have done, right? So work formulas, heat capacity will be there. Let me see what are the other things. Gibbs-Helmholtz equation, delta U, delta H relation, all these things will be there, right? Okay. Do you want me to do thoda sa little bit? Tell me. Tell me, tell me, tell me. Tell me. Whatever you want, I can just tell you then three. I'll not take, then I'll not do work, isothermal process and formulas and all. I'll not get into that. I'll just teach you little bit about it. Okay, little introduction I'll give you about it. Okay, let's do that. Little introduction I'm giving you. So on the basis of this particular formula that you have, internal energy formula, that is delta U is equals to Q plus W, right? Delta U is equals to Q plus W. First thing is that, ma'am, for an isothermal process, when there is temperature change is 0, if delta T is 0, delta U is also 0. So you can say delta W is equals to Q plus W. If I am saying this is 0, then Q is equals to minus of W, right? Now remember one thing, that means I can say that when work is done, when this will be positive, this will be negative, and this will be negative, this will be positive, because they have opposite sign, right? That means when work is done on the system, heat energy will be released. When work is done by the system, heat energy will be required. These are the statements that you must know. That you can say for an isothermal process, internal energy is zero, and whenever work is done on the system, heat energy is released, right? So heat given to the system, whenever you give the heat, whenever system absorbs the heat, work is done by the system. Heat given to the system under isothermal condition is used in work done by the system. So you can see why we have not written work done on the system, because if this is positive, this is going to be negative. So these are the statements that you will know, get to know. You don't have to learn these statements, you just have to see these. There is no cramming part here. You don't have to learn these, you just have to apply that process in the first law of thermodynamics. That's it. I'll do it again for adiabatic process. If you see in adiabatic process, delta U is equals to Q plus W. Now I can say that here Q is equals to 0 for an adiabatic process. That means delta U is equals to W. That means if this is positive, this is also positive. If this is negative, this is also negative. That means, can I say this work is done on the system whenever internal energy is increasing? If internal energy is decreases, that means U final is less than U initial. In that case, work is done by the system. So simple is, work done on the system brings increase in internal energy. On the system, increase in internal energy. So you don't have to cram these things. You just have to see that how to apply this thing. Here is increase in internal energy. Okay, you don't have to cram anything. That's the, this is, right? Next is cyclic process. Let's talk about cyclic process. In cyclic process, all the state functions are zero. So when you apply this, delta U is equals to Q plus W, right? We know that this is going to be zero. And you know, one very important thing here you must write for adiabatic process as well, that delta U is equals to W adiabatic. This is important, right? Okay. Now, if I say delta U is 0, that means Q is equals to minus W. So, if I say Q is equals to minus W, isn't it same as isothermal? If this is positive, this will be negative. If this is negative, this will be positive. That means if work is done by the system, heat energy is absorbed. If work is done on the system, heat energy is released. And this is what is written here. One of the applications is that amount of heat absorbed by the system, forms the surrounding is from the surrounding is equals to work done by the system. Whenever heat is absorbed, work is done by the system. Okay, tell me. Right, everybody? Yes. Tell me if that is clear to all of you or not. Right? That's simple, isn't it? That's simple. Now I'll talk about isochoric. Last two things, okay? Last two things. Isochoric process. If the system undergoes PV work, if I say the system undergoes PV work, right? That is work is equals to minus P delta V. Now, if you see this thing, delta E is equals to Q plus W. Now, for an isochoric process, delta V is 0 and work is equals to minus P delta V. If delta V is 0, then work is also going to be 0, right? So, if work is 0 in case of isochoric, that means this is a very important thing. Write this very, very important formula. Here we can say if this is 0, that means Q is equals to delta U. That means heat at constant volume is equal to internal energy change. That is very, 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 very important statement. right? So here also you must know that we are saying that Q is equals to delta U. If I say this is positive, because there is no negative term here, this is also positive, this is negative, this is also negative. That means if heat is gained or absorbed, then this is increasing. If heat is released, then this is decreasing. Internal energy is decreasing. So you can see this over here. You can see this over here. Heat given, that means whenever heat is absorbed by the systems, heat given to the system under constant volume is used in increasing the internal energy, because gain means internal energy will increase. Heat supplied to the system is stored as its internal energy. That means whenever you give heat to the system, it will remain in the system because the system is not doing any work. So this system is going to have that. See, for example, someone is giving you something and you're not going to use it, so it will stay with you, right? So same thing, if you're giving it some heat at constant volume, it will stay as internal energy. Internal energy is going to increase in this case, right? Okay. Last is for isobaric process. What is isobaric? The system at constant pressure. Now this is quite interesting. If system at constant pressure, you have at constant pressure, that is isobaric, right? Acha, see one thing, this is a formula that you will do later on as well, that what is QP? QP is equals to, we know that delta U is equals to QP plus W. QP, why Q is becoming QP? Because it's at constant pressure, right? That means QP is nothing but delta U minus W. W is nothing but P delta V. So you can write this as U2 minus U1, that is for delta U, minus of P V2 minus PV1, right? Minus minus will become plus here, right? Or you can just write it as this is U2 minus U1, right? And you can also write it like this. Yes. Okay. Now what you will see, this is U2, and this is what this is. Let's say, wait a minute, this is minus V2, PB2, this is minus minus plus. Okay, we have just rearranged these things here, right? So this is U2 plus PV2 minus, if you see this here, this is nothing but this is U2 plus PV2 minus U1 minus PV1, right? Okay, and in this case as well, Achha, that is the thing, na? That is the mistake that is there. This is supposed to be minus of P delta V. Okay, I'll just correct this here. This is supposed to be minus of P delta V. What is work done? That is minus of P delta V. Okay, now if you see this here, this is U2 minus U1, this is minus minus plus, this is PV2 minus PV1. Okay, now you see U2 plus V2, U2 plus PV2 minus of U1 plus PV1, right? Now you will get it, right? Then what is this? Now always remember H is equals to U plus PV. This is important. This we will do later on in next chapter. Why H is equals to U plus PV. That's a very important formula that we are going to do further in the chapter, right? So this is U2 plus PV2 is nothing but H2. This is H1, and this is a very, very important thing, that heat at constant pressure is enthalpy and heat at constant volume is internal energy. It's a very important statement, right? So you can write this here as well, that QP is equals to delta H. So if you say this is positive, this is positive, this is negative, this is negative, that means if heat is gained, then enthalpy increases. If heat is released, then enthalpy decreases. So you can say heat or enthalpy or heat content of the system is defined as the sum of internal energy, and this we are going to see in the next class, that why this formula is there. Okay, rest, so this is all in the same way only. Wait a minute. This is all the same way only. Rest of the things, guys, we are going to do it in next class, that what is the work formula for reversible, irreversible, all these things we'll do in the next class. Okay, because that is going to take time. Let me see if this was, no, this is actually a question which you'll be able to solve in the next class only. Okay, right, everybody? It's a very important thing. QP is delta H, QV is delta U. Next lecture is going to be very important. You will see so many questions in next lecture. Work questions, you will see heat capacity questions, you will see gamma questions, you will see Gibbs-Helmholtz, you will see delta H, delta U relation. All these are very, very, very important topics that you must do. Okay? Yes, everybody? Okay. Yes. Okay, Anjali, sure, sure, I'll do that, right? You also, I'll provide you with the notes. And also, guys, very important thing for you and very interesting thing for you. Can you see this particular ask Ved any doubt? Right? Ved is your friend, new friend, right? Instead of making some random person your friends on YouTube chats, make these your friends, right? So ask Ved any doubt, click over here, right? And you will get to this particular portal. Oh my god. Oh. Wait a minute. Okay. Yes. Don't worry, that's not my number. Right? So let's see this here. Wait a minute. Wait a minute. Yes. So this is what, this is your YouTube session that is going on right now. Right? And what you can see in this with AI, you can ask doubts here. Wait a minute. For me, it is not showing. For me it's not showing here, right? On laptop it was showing, I think on maybe on screen it is not showing, right? Okay, so what you will see here, that when you will come to this particular portal, right, you can ask your doubts here, right? So whatsoever is your doubt regarding the class, you can ask it over here to the Ved AI, right? You can ask your doubts regarding this lecture. You can ask PDF also now, because it's 11 a.m. So PDF will be uploaded by tomorrow morning. So that will be also on the same link. You click on that, PDF of this lecture will be provided. Any question, any doubt you have, you can ask this to Ved AI, right? Okay? Yes. Chal. Okay, next lecture is going to be on 28th, right? 28th at 6 p.m. you will have your class, right? Okay. Okay then, guys, I'll see you all in the next class. Till then, bye-bye. Take care. See you all next class. Bye-bye. Wait a minute. And one more important thing I forgot to tell you. I just realized that thing. If you go to this thing, and a very important thing it is, and you click on the live section here, you will see that on 3rd of December there is a Eclavier rank booster test series. That everything about it, Shreyas sir is going to inform you, that he is going to tell you, right, what will be there in this particular test series, right? And this will be live on 3rd of December, right? So we stay tuned to this particular channel and smash the like button here to mark your attendance, right? Okay, so that's it for today, guys. Till then, bye bye. See you all in the next class. Bye bye.